Assalamualaikum warahmatullahi wabarakatuh and good morning to all my students. Okay, so right now, as you see on the screen here, on we call the screen, we are now in topic of 5.2 composite function, the topic of function and graph. So before we continue, I do hope that all of you may continue supporting my channel by click to the subscribe button, like, share, and bell notification. So I do hope that all of you will enjoy it and get benefits from all my my videos. Okay, so for today we're going to look into a composite function using an arrow diagram. Okay, and then we're going to find the composite function, and finally find the composite and other function which are given then. Okay. Okay, so consider two functions of f and g. The composite function of f and g is written as this one, as you see this here now, fg or f naught g, and it's defined as this one here. And please note that f naught gx is not equal to fx multiplied with gx. Okay, so we represent in arrow diagram where the element of x, when they substitute into the function of g, then we get it gx, and with element of c here, when we substitute the function of gx into the function of f, then we get fgx. Okay, example 1. So now for example 1a, where the function of fgx, so then gx, substitute the function of g with 2 minus x, and substitute the whole function of g into an x of the function f, which is 3. X here we substitute with 2 minus x plus 1. Okay, so 3 times 2 equal to 6 minus 3x plus 1. Then 6 plus 1 equal to 7 minus 3x. There you go. For b, okay, for b, gfx. So then, function of g first, and fx, which is 3x plus 1. And then substitute the whole function of f into nx. Okay, I'm sorry then. Okay, sorry then. I have a problem with this pen here. Okay, and substitute the whole function of fx into an x of the function g. So then 2 minus x, which is 3x plus 1. Okay, so then 2 minus 3x, negative times positive is negative 1. So then negative 3x, 2 minus 1 equal to 1. Okay, so now f naught, the function of g naught f. So we have found that this just now in question of b. So we substitute this function g naught f, okay, g naught f, which is negative 3x plus 1, substitute into an x of the function f. So then here f, g naught f here with negative 3x plus 1. So substitute everything here into an x of the function f. So 3x, negative 3x plus 1 plus 1. Okay, so then 3 times negative 3x, negative 9x. 3 times 1 equal to 3 plus 1. Okay, so negative 9x, 3 plus 1 equal to 4. There you go. Okay. Okay, never mind. Recall, we have solved this earlier, just now. Okay, never mind. Okay, example 2. Now, we have a different of what we call composite between f, g, and h. And this is a function of f, g, and h. Okay, I rewrite the function of f, g, h from the previous page slide. Okay, now let's solve this one by one. F, g, x. So then f, gx equal to x squared minus 3. So substitute the whole function of x squared minus 3. Okay, substitute the function of fx, gx, x squared minus 3 into an x of the function f. So 1 minus, okay, x, which is x squared minus 3. Okay, so 1 minus x squared. And then negative times negative, positive 3. Now it becomes negative x squared 1 plus 3 equal to 4. Okay, question B. G not f. So then g and fx is 1 minus x. Then substitute the whole function of 1 minus x into an x of the function g. Okay, into an x of function g, which is x squared minus 3. Okay, 1 minus x squared minus 3. And then 1, expand this. Okay, so it can give you 1 minus 2x plus x squared minus 3. So rearrange from the highest degree of x squared here, minus 2x, 1 minus 3 equal to negative 2. Next, gx. So gh, which is 2, divided by x. Okay, substitute hx, or 2 over x, into an x of the function g. So then, okay, sorry. Okay, so g, which is x squared minus 3, and this is 2 over x squared. Okay, so 2 squared equal to 4 divided by x squared minus 3, and change this in the form of what you call substitute, multiply with x squared and over x squared. So we change this in the form of denominator, and then we come up with 4 minus 3x squared divided by x squared. There you go. And then hg, h and g is x squared minus 3. So then substitute x squared minus 3 into an x of the function h. So then it come out with 2 divided by x, and substitute x with x squared minus 3. Okay, next, f and h. Okay, f, h, f. So what about h here? Is 2 divided by x. And substitute the whole function of h into an x of the function f. 1 minus x, and it is 2 over x. Okay, so then change this in the form of denominator in the fraction with the denominator of x it is now x over x minus 2 over x, and simplify this as an x minus 2 divided by x. Okay, so class, which I think that is either you leave it in this form, or actually that in this form is more than enough. Okay, 1 minus 2 over x. Actually, I think that this is the simplest one. Okay, now f, g, and h. F, g, and h. H is 2 over x. Substitute hx, which is 2 over x, into an x of the function g, x squared. So then, it is now x squared minus 3. So substitute this here, 2 over x. And simplify this, it gives you 4 over x squared minus 3. And substitute the whole function of g and h into an x of the function f. So now 1 minus, okay, 1 minus. Now it is 4 over x squared minus 3. Okay, so it is now 1 minus 4x squared minus 3, negative and negative positive. So it is negative 4 divided by x squared plus 4. Okay. So which I think that with all this example, f and h, can you recall, can you try by yourself? I gave you example of A, B, C, D, E, and G. 6 examples. So I do hope that all of you may try by yourself, find the answer of this. Okay, HF for the question of f, HF, the final answer for this one here. Okay, try by yourself. It is 2 divided by 1 minus x. And this one here, for h, for the final answer, you should get here is 2 divided by x squared minus 2x minus 2. Okay, try yourself and hopefully you can get all these answers, or recall these questions correctly. Okay. Example 3. So fx given as x minus 1, gx x minus 1, and gfx equal to 3 minus 2x. Okay, this is a different situation here now. Just now, we given to us a single function of f and g, and we combine it. It's a process of composite function to get gfx or fgx. Right now, it gave you a function of g and a composite function of gfx. So the question wants us to find fx here. Okay, so gfx equal to 3 plus 2x. And composite function is a process where we substitute the function of f into an x of the function g. Meaning, if this is g, okay, sorry again. I'm new with this new pen of Vic, so okay. So then, we are going to what we call substitute fx, substitute the term of fx into an x of the function g. So now it is fx minus 1. You know what I mean? So fx, we substitute fx. Fx is the question that we like to find out now. Find out after this, okay? But we substitute fx into an x of the function g. So we get fx minus 1, then fx equal to 3 plus 2x plus 1. Negative 1 bring here become positive. So 3 plus 1 equal to 4 plus 2x. That's it. There you go. And next example, if gx, find gx. Okay, if given fx, okay, just now the question gave us a function of Okay, I define this as a g fx. For example, this is a function inside and this is a function outside. Okay, just now, example 3, we like to find the function of fx, which is inside. Okay, fx substitute into the function of into an x of the function g, fx inside. Now, we like to find the function of g, which is outside, waiting outside here. We're given the function of fx for this one. Okay, so now, okay, so just imagine if I rewrite it here, g fx equal to a function of g, okay, and then substitute fx, x plus 1 here, x plus 1, okay, and we compare with this function inside here, g fx. Okay, I should think that I'm gonna write this one here. Okay, g fx equal to g fx, which is x plus 1, equal to x squared plus 2x plus 2. Okay, sorry. Okay, g fx, which is g fx equal to x plus 1 equal to the whole function of g fx here, x squared plus 2x plus 2. Okay, let u equal to x plus 1. Okay, substitute and we replace the x plus 1 with the u here, and we come up with an equation of x equal to 1, bring the other side become negative, it become u minus 1. Okay, so the reason that we change this, because we are going to substitute x of u minus 1 here and here. Okay, so then gu, where x plus 1 equal to u. So gu equal to, then substitute x with u, which is, substitute x with the term of u, which is u minus 1. So then u minus 1 square plus 2 times u minus 1 plus 2. Okay, so expand this u minus 1 square, give you u squared minus 2u plus 1. 2 times u equal to 2u, 2 times negative 1 minus 2 plus 2. Okay, so 2 minus 2 equal to 0, u squared, negative 2u plus 2u, 2u minus 2u equal to 0, and plus 1. Okay, so then our gx equal to x squared plus 1. Okay, so class, this is it. A few examples for our lecture for this second part. And so with the conclusion here, which is, sorry. Okay, so I'm sorry for that technical problem with this. So that's all for today, and I do hope that this video helps you to understand the process of composite function. And that's all for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.